Today we're going to be looking at precipitation reactions. In this reaction, we're looking at aqueous barium chloride and aqueous copper sulfate. So the first step we need to do is have a look and see what the ions are. So barium has an ionic charge of 2+. Chlorine has an ionic charge of -1. Copper has an ionic charge of +2, and sulfate has an ionic charge of -2. We have a problem over this side because barium has a charge of +2 and chlorine has a charge of -1. What that means is that we need to have 2 chlorine atoms for every 1 barium. As you can see, 2 chlorines for every 1 barium. However, our copper has a charge of +2 and our sulfate has a charge of -2, so we only need 1 copper and 1 sulfate. The next step is to see what happens when this reaction takes place. So we look at the cation in the first section, and the cation is barium. So we're going to put barium on this side, and we're going to look at the anion from the copper sulfate, which was the sulfate, and we're going to join them together. So we make barium sulfate. Then we look at the cation in the copper, that there, and then we look at the anion in the chloride, pop that there, and I'll put a little plus sign in because we need to make sure we have a plus. Now we're going to check to see what their ions are. So back to barium. Barium has a charge of 2+. Sulfate has a charge of 2-. Copper has a charge of 2+, and chlorine has a charge of -1. So we can see here that copper's charge and chlorine's charge aren't the same. So what we need to do is have 2 chlorine ions so that we have 2 times -1, which is -2, which means 2 plus, 2 minus, that means we've got it balanced. So because of that, we need to have 2 up here with the copper chloride. Now we have 2 chlorines for every 1 copper. 2 chlorines for every 1 copper. 1 barium and 1 sulfate. So at the moment we're looking good. So now we need to make sure that we're all balanced in our top equation. So we've got 1 barium on this side and we have 1 barium on this side. 2 chlorines, 2 chlorines, 1 copper, 1 copper, 1 sulfate, 1 sulfate. Now the equation's balanced, but what state is the barium sulfate and the copper chloride? So now we need to have a look at our solubility table. And so the solubility table says that when we look at these equations, let's have a look at the sulfates. The sulfates says most sulfates are soluble except for calcium sulfate, strontium sulfate, barium sulfate, silver sulfate, and a couple of others. So here we have barium sulfate. Most sulfates are soluble except for, because this is an exception, barium sulfate is a solid, and this will cause it to form a precipitate, the precipitate of barium sulfate. And how about our copper chloride? So the solubility rules state that most chlorides are soluble except for silver, mercury, lead. We're looking at copper. Copper chloride is soluble. So copper chloride is written with an aqueous in that space. So now the question is, did we have a precipitate? Yes, we did. Our precipitate was barium sulfate. And then what was left over? We had spectator ions. Our spectator ions were copper ions and chloride ions. And the interesting thing about it is, for every one copper ion that was in spectators, there are 2 chloride ions. Okay, I hope this makes sense. We'll try another one.